You send this and moment later your backend give you this JSON output. That looked pretty simple, but what actually happened between buy now and this response? How did the backend validate the request? Who calculated the total? Who generated the order ID? And what happens when something go wrong? Today we are going to build that entire flow from scratch. This video is a part of a series where we are building a production style backend from scratch and gradually evolving it into an event-driven microservice architecture. But don't worry if you haven't watched any previous video. Every video in this series is designed to stand on its own. Today we are focusing on one problem. How do you actually design and build backend behind an order? We'll start with the API design, build the models, implement the order flow, test it, and then I'll show you the first problem with our design. By the end of this video, you'll have a working order API running on your machine. Let's build it. Let's keep the problem extremely simple. Imagine an e-commerce application. A customer clicks buy now, the frontend sends the backend two things. Who is placing the order and what are they buying? Our backend then needs to validate the request, calculate the total, create an order, give it a unique ID and return the result. That's it. No payments, no Kafka, no microservices. Not yet. We are starting with the smallest system that can actually solve the problem. And that is important because later, when the system becomes more complicated, we'll know exactly why each piece was added. Okay, so let's set up our project. I have already created a folder named OrderFlow, and now inside this, we'll create a virtual environment where we'll install the FastAPI. So I'm just running the command one by one. This will activate that virtual environment, and then we'll install the FastAPI using this command. Okay, so the FastAPI is there now. Let's start building the project using main.py file. So I have created main.py file and also imported some of the libraries that we'll be using to build this application. You can also do the same and copy and paste it on your VS Code. So now let's get to the part which actually matters. How do we model the order? Let's start with the first important thing that we need, which is an order item. So think, what should we need in order item? We should know the product ID. We should also know what's the quantity of the product, and we should also know what's the price of that product. So we can simply create a class like this, which will have all the information. So the class name is OrderItem, which will have the product ID, which will be the integer in our case, and quantity will again be integer. And you can see here, we have used field greater than equal to 0, which means the quantity should always be greater than 0. And similarly with price. So for example, if someone orders by some mistake it became negative, it can right away reject here instead of going to all the way to the services. So that's why we are using the Pydantic here, because this helps us to create and do the checking in the class itself. So an order isn't just a data. It will start from somewhere and it will end. For example, you started an order as a pending state, and towards then maybe it will be confirmed, or it can also happen that it's cancelled. Maybe you have cancelled it or someone else has cancelled it. So for that, we need to create a class which will be of enum time, which will store all the information like this. So for example, if a new user come or a new developer come and start developing on this application, they will make sure that the proper naming convention is followed, so they cannot create any new name, for example, cancelled order or something like that, instead of just using it as cancelled. So now let's design an order itself. So here we'll have the ID, which will be the UUID for that order. And the order will obviously belong to a user. So for that, we have a user ID, and it will consist of items. It can get multiple items. That's why we are storing it as a list of order item. And it will have some total value attached to it. For example, what's the total cost of that whole order? And it will also have some status. So now look at these fields: user ID, items, total, and status. Do you think customers should allow to send this? Probably not. So we need to create a separate data model, which will be used by client to send the data, and this will be handled by server. So this separation is something I want to keep throughout the series. The client provides the input, the server generates server node state. Now let's make that explicit in code. So this is the class that will be exposed to client. So here if you see, we are creating an order request. So for that, the important thing is the user ID, because we should know what user ID requested the order, and also what all items belong for this order, so we can compute the price and everything after that. Now we need somewhere to put these orders. For now, I'm going to make a deliberately bad choice. And this is important. I'm going to use an in-memory dictionary. Think of this as our temporary database. And I already know it's not production ready. If this server restart, everything disappears. But that's okay. We're going to use this bad implementation to understand exactly why we eventually need a real database. So now let's implement the buy button that frontend will call. So this is the post method that frontend will call when someone submits the order. So first step is we'll create the order ID based on the UID, and then we'll create the total value. Basically, we will know the item price and also the quantity of the item because we are already getting it from here. So once we have that, we can calculate the sum using the total or a for loop basically. And once we have the sum, then we can create the order, so that for that, the only thing we need is the total, which is already known to us, and also the status which will be pending in the initial case. And once we have everything for order, we can just insert that to our dictionary. So for now, we are using the dictionary, but in reality, it should be a database. So creating the order is only half the problem, but we also need to retrieve the order. So for that, we'll create a GET API, which will fetch the order based on the order ID and then give us all the information of the order. Here we'll check if order is none. Like for example, if order is none, then we need to raise, okay, like the order not found. But if we found the order, then we need to return the order. And remember here, the order will have all these properties. So if someone fetched the order using the get order, they will know everything about the order, like who was the user who placed that order, what are the items, and what's the total value of that order, and what's the current status. So the total application is just this. In the initial part, we have created the data models, and towards then we have created two functions. One which will post the order and then calculate all the prices and insert that to our dictionary in orders. And the second function is just the get API, which will be used. For example, if we need to fetch the if we need to fetch the order based on the order ID, we can just hit the get order and then it will give us the order. Now let's start the application. I have already started it, but you can use this command to start the application, which is uvcon main app reload. And once you start the application, you can open the port 8000 and you can see the docs. Like if you go to this URL, you'll see like everything what we have created. We have one post method and we have one get method. So now we can test it basically just hitting it with the schema or the JSON object. So here, if I pass user ID as 1, 2, 3 items and quantity and price and everything, so we'll get the output that we expected. So if you hit the execute button, you will get this, which is what we expected. So the response will be, the total value will be 998 because the quantity is 2. So it multiplied the quantity with the price and returned us the total. And as you can see, the status is also pending because like this is the first time the order is getting generated. So by default, it will be at pending. So now let's test the guest API that we have created. So for that, we need to copy the order ID that we need to fetch. So here, since we already know we have already created an order ID, so we can directly copy this from here. And then here, if we execute the order ID and then hit execute, then we should get the order. So yeah, so if you see here, we got the correct order. We got the same order. And again, like the status is pending on total value is 998. So that's how like we have created two APIs. One is get, which will give us the order based on the order ID. And one is the order generation, which will create the order based on the user schema that it will be sent, like user ID and items and price. So now let's test something interesting. Let me start the server. So if I do Control C and then again start the server. Okay, so the server is started now. And then let's try to retrieve the same data which we have created again, and then let's see what's the response we'll get. So this is the data that we already have. This is the order ID. And suppose now if I hit execute, you can see that like the order detail is not found, like order is not found. Why it happened? It happened because like we're not storing the data in any database. We are just storing it inside a dictionary. So this will only be store the data till the database or till the application is alive. Once we stop the application and again start it, this will be gone. So that's why we need to have a database. And there's an even bigger problem. Imagine we run two instances. If an order is created on instance A, instance B doesn't know it exists. So we can't properly scale the system. And this is actually the most important part of today's video. We didn't need Postgres because I decided. We need it because our current design has a problem. Our data needs to survive restarts and multiple application instances needs to access the same data. And that's what should drive architecture decision. The same thing will happen throughout this series. We'll introduce Redis because we have a caching problem. We will introduce Kafka because we have an asynchronous communication problem. We'll introduce microservices because we have a series boundary and scalability problem. The architecture should evolve because the system problems evolve. So let's recap what we built today. We started with a simple buy now flow. We created an order API. We used Pydantic to validate incoming data. We separated client-owned data from a server-owned data. We calculated the order total on the backend. We generated a unique order ID. We also created and retrieved order. And then we deliberately broke our simple design and discovered why in-memory storage isn't enough. So even though this is a tiny application, we have already made our first real architecture decision. And now we have a very obvious next step. Our orders needs a real database. So in the next video, we are going to this exact OrderFlow project and replace the in-memory dictionary with PostgreSQL. We'll model user, order, order item, product. We'll connect Postgres to FastAPI, persist real orders, and then restart the server. And this time our order will still be there. But again, you don't need to watch this video to understand that one. Every video is designed to stand on its own. For now, we have our first working version of OrderFlow. And this is where the system starts.